Hi everyone, it's time to talk about the inverse trigonometric functions. The good news I have for you is that we will only take a look at inverse sine, inverse cosine, and inverse tangent, and we'll call ourselves done after that point. And also the good news is that you already know quite a lot about inverse functions. See the review to the left. I've kind of given you some questions to think about. If a function is going to have an inverse, then it needs to be 1 to 1. So the questions you ask yourself are, does the function pass the vertical line test? Does it pass the horizontal line test? If it does, then how do you get the inverse? Well, you do so by exchanging x and y and solving again for y. And the result is the graph of the inverse function is symmetric to the graph of the function about the line y equals x, which means the domain and the range values swap. So we know quite a lot about the inverse trig functions without even talking about them. Now, here's where it gets a little tricky. Sine of x is not a one-to-one function. It repeats infinitely. So what we need to do is restrict it to a section that is one-to-one and that contains the full range of sine. Now here's one possibility. Okay, here's another possibility. And another. And you could keep going on along those lines. So we're going to use the one that I have highlighted in blue, closest to the origin, that sits inside a window between x equals negative pi over 2 and x equals positive pi over 2 and y equals negative 1 to positive 1. Okay, so here we are. We have restricted to a one-to-one portion of the graph that has the exact range of the entire sine function, and that part is important. Okay, we want it to replicate or behave like sine of x. Now, if this is all we're finding the inverse for, then when we swap x and y, we're swapping ordered pairs like the following: pi over 2, 1, 0, 0, negative pi over 2, negative 1. In doing so, we get ordered pairs like negative 1, negative pi over 2, 0, 0, and 1 pi over 2. Okay, and if we reflect about the line y equals x, which if we were to draw that in here, would hug along these lines like so. To be a little careful drawing it. And so the reflection, you can see, would be as follows. And that's what I've drawn and screen captured in red to the right, is the inverse sine function is the result of swapping x and y for the sine function in this window. Now this means your inverse sine function has a very set domain and range all on its own. Its domain is negative 1 to positive 1, and its range is negative pi over 2 to pi over 2, and we can get those from exchanging over here. Okay, but the trick is this is all you get. So when I say something like, sine inverse, I'll give you the words here, of 1/2 equals question mark, then I'm thinking, okay, if I have the value 1/2 in the window for sine, then it would have to be the angle pi over 6 in quadrant 1. That would be my only option in this window. So the question mark here is the angle in the interval that we have chosen whose sine value is 1/2. So you have to be willing to go back and forth here to work with these. Now, notation. One common notation for inverse sine is to use the word arcsine. Another one is to use the terminology sine inverse. It's accepted in most computer algorithms to use arcsine, although it's widely accepted in handwritten trigonometry to use sine inverse to look like F inverse. Okay, you need to follow the structure of the platform we're using, which is WebAssign, which means you're always safer using arcsine for it to understand what you're talking about. But again, the trick is you're only working in a small window. Now we're going to define inverse cosine and inverse tangent in a similar fashion. So bear in mind that you really need to accept the window that we've chosen and go with it. And it may feel awkward at first until you get used to it.